clarify. This is the wave. Correct. This is how now we have to get. And right, we have to get this one. This I'll come to the later. And the particle is vibrating right from this position. This position x is equal to 0, and this position x is equal to a. I want to find out the displacement at any instant of time. This was when I derived the equation. I would have told you that at any instant f is equal to 0, right? This is a part now. I just want to give the clarification. There you would have written x double dot, right? F double dot is one force, that is F applied force, correct? Then you would have written this force, the restoring force would have written, right, is equal to 0. Then you would have written FA minus of FR is equal to 0. This is M into A minus of minus KX is equal to 0. Or you would have taken X double dot is A plus K by M into omega into X is equal to 0. This is what you would have written, right? There was a question which is coming here, right, at this point here, at this point. Let us not take in this way. At any instant, you can write directly this equation. That means the direct equation here is this one particular step you can change. That was there's some one girl and one boy. Now they were asking this question, right? I did not give the clarification correctly, and you can just make it this way. That is, F applied force is equal to minus of Fr. This is what I want to say. The restoring force is nothing but the force with which the body is moving. Correct? Then this step comes here. You will be able to get this equation. All right? This is minus. This is given by this. So I put plus here. Becomes minus. And F of R is equal to minus X. And you get this equation. This is the only clarification I have.
Excuse me, sir.
Yes.
Can you record the session?
Okay. Fine. So the clarification is this. That is, at any instant of time, the force acting on the body is given by the restoring force. Restoring force is minus of K into X, as all of you know. Correct? And Fa is M into A, Newton's law of motion I have used. M into A I have used. Correct? This M into A is force with which the body moves. And this is minus Kx. And when it comes here, it will become plus Kx is equal to 0. That's what I have used here. And we have found that A is equal to K by M into X. But already we know the formula that A is equal to minus omega square X. Correct? This also becomes minus because we have brought to the other side. Therefore, I can write the equation X double dot plus omega square X equal to 0. From there only we started. And we have got the equation. We have taken the acceleration as d square x by dt square. And this, correct, is d by dt of dv by dt. No. A is this, dv by dt. Correct? A. And here I have written this value dx by dx. Now I've changed, and from there I got the equation. This I would have written dx by dx. All of you follow that one, whatever I have given there last class. It will be easy for you to do this. And from there I would have found the equation v is equal to omega into a square minus x square square root. This is the equation you would have got last class, plus or minus. I'm going to start it from this only. Hope all of you understood this one clearly. So which is not the last class? Last class, whatever I given here, this part you can strike out and you can take it from this. Perfectly right. Or you remove this one completely, you can take this. Okay, this is what now we have seen last class. Now I want to find the solution for the other part. Let's see that. Okay. Now, solution to find out, this is a continuation of last class. We know that V is equal to omega into a square minus x square. Correct. Here I put plus or minus because both values, because square root was coming. So I need to put both positive and negative sign here. Now, I want to change them. I want to modify the equation and I want to get the solution for this. That will be coming in terms of x. So we know that V is equal to dx by dt is equal to plus or minus omega into a square minus x square. Or I can write here dx, x one side I'm bringing a square minus x square equal to plus or minus omega into dt. I take it as some equation, maybe a third equation I take. Now I want to consider only positive and I want to get the equation. Then I consider negative and get the equation. Considering positive value, I get dx divided by a square minus x square is equal to omega into dt. Correct? Positive value I calculated. If this is positive, this on integration, so I write this step here, on integration, if I integrate this one, dx divided by a square minus x square is equal to integral of omega into dt. Remember the integral that I used here does not have any limits. Okay, if there are no limits, then I have to put a constant of integration. Right, that part it must be very clear. Okay, so now what I do, I go to that. On integration of this one, this becomes a sine inverse of x by a. It's a standard equation. You will learn it in mathematics also. You would have learned it in mathematics. Is equal to, if I integrate this one, I get omega t plus c, where c is the constant of integration, which must be calculated for boundary condition as you know here. This is omega t is nothing but your radiant displacement omega t. So dimensionally, this also must be radians. So omega is angular velocity and t is the time. Angular velocity into time will give the angular displacement. So this should also be angular displacement. That I call it as, instead of c, I'm going to call that as phi, called phase. I want to use the word phase, but as the initial phase I can call it. Therefore, x by a is equal to sine of omega t plus phi. And I've taken multiply by sine both sides, sine inverse and sine will cancel, you get this much. Therefore, x is equal to a sine of omega t plus phi, where phi is the initial phase. Okay. Where phi is the initial phase. Where phi is the initial phase with units radian. Remember radian. It must be taking the unit of omega t. Dimensionally, only then we can add this. Okay, this is the first part. I take it as the fourth equation. Then considering the negative value. When I consider the negative value, I get the equation dx a square minus x square, is that right, is equal to minus omega into dt. But if I integrate on integration, what it has become sine inverse, but here it is minus, so minus sign can be put here. So I put minus sign here, I remove this part. Correct? So I put a minus sign this side. So this becomes on integration of this one. The integration of this, if I integrate this, correct, minus of this much becomes cos inverse of x by a because of the minus sign, equal to, again same thing, omega into t plus some phi we get here. Phi is nothing but the initial phase. This phi and this phi will be of the same value. Okay, therefore I can write x by a is equal to cos omega t plus phi. So x is equal to a cos omega t plus phi. So two equations I have got. Which equation I am going to use now? Which equation I am going to choose? That matters now. Right? There are two equations I have got. One is here, another one is here. But when I put x is equal to this, x equal to 0, x equal to 0, right? You can find the velocity equation also there. When I put x equal to 0, the velocity will become maximum. So the preferred equation for you is this. I'll come to that one slightly later. So because the angle between the cos and sine varies by 90 degree. So sine theta plus 90, I'll be able to get cos. So it varies by which one 90 degree here. So the preferred equation for our vibration case is equal to 0. What actually it means here? Where you are taking a displacement from, correct? Suppose you have a body, it is vibrating like this, correct? If you start taking the time from here, this equation is used. If you take the time from here, if t is equal to 0, and this time becomes what? You will be getting this equation. The displacement can be given by this. When t is equal to 0, you put here t is equal to, initially let us say phi is equal to 0 and check how it comes. When I put when initial phase equal to 0, and t is equal to 0, I put t is equal to 0. When I put t is equal to 0, cos 0 is 1, so x becomes a. X becomes a. In that case, I'll use this equation. That is when t is equal, when I start from here. When I start from here, this point, remember this point here, t is equal to 0. And if I put t is equal to 0, see, t is equal to 0, the displacement is 0. So t is equal to 0, if I put here, already phi is taken to be 0. T is equal to 0, sine 0 is 0, so x equal to 0. So you prefer this equation. So for this case, t is equal to 0 at base, I prefer this equation. For t is equal to this case, I prefer this equation. Both the equations are perfect. That depends on from where you are starting the body. If you start the body from the maximum amplitude, then that you go for cos theta value. If you start it from the mean position, you will use it with the sine theta formula. That's all. Otherwise, there is no difference here between this and this. Hope you understood this. Right, so two equations I have got it. So I have solved the differential equation. I have started from this velocity. D is dx by dt. I got this equation. Dx by, I brought to this value here, plus or minus dt. I have both positive sign, negative sign. First, I consider positive sign. And after doing this integration, I get sine inverse of x by a for this. Then I'll be getting here omega dt plus phi. So h by a is equal to sine omega t. This equation is used when the time it is starting from the mean position. Then I put another one considering the negative value. I get cos of theta and I get x equal to a cos omega t to phi. This equation is applicable only when I started from the mean position, t is equal to 0. So both the equations are allowed. That depends on where you are starting the time, whether it is started from the mean position or it is starting from the extreme position. This is what I just wanted to teach you, and I want to give you some more related ideas. Shall I go to the next part? Understood?
Excuse me, sir.
Yes.
So phi is usually between two bodies, like phase difference is usually between two bodies, and here only one body is moving. So that's kind of confusing me.
Okay, look at this one. She has asked this question very rightly. What I mean to say here is, if it is starting from here, x equal to 0, t is equal to 0. What equation you are using? Is that right? Here it is starting from this 0, phi can be 0. Correct? If it is starting from here, I can put phi of 0, I'll come to that one. If it is starting from here, your time t is equal to taken from here. What will you put? This phase, the phase here, how much radiant is covered in order to come to this one, that is given in terms of phi. That's all. Let us say, graphically, I can give like this. If it is starting from this one, phi becomes 0. If it is starting from here, I have to count this also. That phi is taken to be here. If still you have a... Yes?
Basically, it's between the mean position and any other position.
Yeah, where you are starting where you are starting your time. Correct?
Okay, sir.
That is,
Okay.
let's say any circular motion also the same equation is applicable. I connect the circular equation here. Now look at this. This I'm taking it as theta. Theta. I'm taking theta. Theta is equal to omega into t. Right? This displacement is omega into t. Is that right? That is the equation. It's a circular motion I've given you now. Right? This will be perfectly a sine angle it will give. A sine variation it will give. Now, if I start the time from here, let us say time is calculated from here, then this must be accounted. That is taken to be phi. So this total angle is omega t plus phi. Then I can write the equation. The displacement is given as a sine of omega t plus phi. I will be teaching you these phases and all later. Now I do not have time to do this. Later I will do this. I will spend about 40-45 minutes on the phase alone. That I will do it later. Maybe next class. Shall I go to the next part now? Hope there is no doubt. You understood this one. Phi at present is the state of vibration, which is starting from t is equal to from any reference time. Let us say you understand in this way. Later we will see this particular part. Now, time being, you've seen and only the solutions A and this. Don't be worried about the circular motion. I will come back to this and I explain to you phi again. Okay, next part. Some little more important parts now as I want to teach you. Okay. Look at the thing. So what I need here. Okay, so now I take this one. Angular velocity or angular frequency. Both of them are same. Omega. The unit of this one also we are going to see. Omega, we are going to see angular frequency or angular velocity. Angular velocity is defined as the angular displacement per time. The rate of change of angular displacement is called angular velocity. It is given as a radian per second is the unit. Correct? Omega is equal to d theta by dt is angular velocity. I want to give one diagram for this one and then to explain this. Look at this. This is the crest. This is a crest. Displacement, maximum displacement. It is starting x equal to 0, it is starting, t is equal to 0, it is starting. And it has completed one oscillations up to this. And it is going to the peak again and it is coming here. This is the displacement x is going here. The time taken for this one complete oscillation is t, as all of you know. And so the here also it must be t. The time taken between two peaks must be t. Correct? So Therefore, so what you want to do here, the time period is given here, and from this end to this, I want to calculate. It is making a displacement this way, and the wave is getting changed this way. The state of vibration here is the maximum, it has produced maximum amplitude, and here also it has produced maximum amplitude. If you take this time, the time here is T1 and this time is T2, then what is the difference in time here now? The difference in the time here between this and this, as all of you know, is T. Therefore, T2 is equal to T1 plus T. Correct? T1 plus T. Hope you understood here. This is T1 and it has completed one wave completely here, right? Producing the same amplitude again here. The time is T2. This time will be equal to this plus the period. As you know, period is nothing but number of, this is the time taken to complete one oscillation. Time taken to complete one oscillation. And we have the formula T is equal to reciprocal of the frequency, and therefore I can write even the frequency also, F is equal to 1 by T, right? So it is given as hertz or per second. I think you can use as the units, correct? And the time taken by this is this much. I want to write the equation for this. I write equation A sine of omega T plus n phi as x1 here, and here is x2, x1, and here is x2. So I write here x2 is equal to A sine of omega T, here 1 and here 2 plus 5. Is that all right? Hope you understood. Right? This is T1 and this is T2. This can also be written because this should also produce A, because here is A and here also it is A. So it should produce A here and here also it should produce A. That means this must be sine 90. This must be 90 plus something. We are going to see that one only, equal to how much radian this is getting changed. That also we want to see is equal to, we have written the time. Correct? Therefore, this can again be written A sine of omega T plus T plus phi. Hope you are able to follow, because T2 is this. I substituted here. That's all. Is it right? So now if we have added something here is equal to A sine of omega T plus omega T plus phi equal to A sine of omega T2 plus phi. Correct? Any doubt in this part? Here is the maximum displacement. Here is the maximum displacement. So this equation must be equal to this equation. Yes or no? Because the displacement is same and here also. Therefore, I can write here where it is coming, x1 is equal to x2. Because both of them are same displacement it is producing. So I can write this equation, A sine of omega T1 plus phi. So I want to connect these equations. Both are equal. So what I'm getting here, this equation is equal to this. A and A you can cancel it. So sine of omega T1, here this becomes T1, okay. T1 plus phi is equal to sine of omega T1 plus omega T plus phi. Now I can remove even which can be removed, even sine also can be removed, right? You can remove the time, sine and sine here. If I remove this, I will be getting this equation and this equation. So I take the initial phase at this phase as phi 1 and this phase as second one as phi 2. So it becomes phi1 is equal to phi2. Therefore, I get omega t1 plus phi1 is equal to sine of, sine is not there, omega t1 plus omega t plus phi2. So now what I do, this and this I can cancel. So I get the final format like this. Phi2 minus phi1 is equal to phi1 minus phi2, phi1 minus is equal to omega t. How much angle phi2, how much radian it is different from here, one complete thing. So this is one complete wave, the radian is 2 pi radian. This is pi radians, this is again a pi radians. So one complete wave, it will be 2 pi radians. So this becomes 2 pi is equal to omega t. So omega is equal to 2 pi by t. So we'll be able to calculate this. So omega is given as the angular displacement divided by the time. See here, angular displacement divided by time. So I don't want you to learn all those things. This is out of my interest, and I taught you all those things. So what is required here is this. The equation is omega is equal to 2 pi by t. You remember only this particular part. So I have taught in terms of phi. I have taught here. I have taken that as a phi1 as a phase, and here I've taken the phase as phi2. Any doubt in this part? Once more, I'll just teach you in a simple way. I teach you. Okay, look at this. In a very simple way, I'm going to teach you. I am taking this way. Look at this. Okay, for easy reference only, I'm taking this point. Okay, this point. Any 2 points can be taken, no problem. Right? For easy reference. This is x. This is omega t. Theta is equal to omega t is going this side. Okay. Or a t or t also you can take, or you can take it as t here in this direction, anything. Now, if omega, this is the position I'm taking. From this position to this position, the time taken by this is t. This is time t1, this is t2. So this time is t. Therefore, t2 is equal to t1 plus t. What is the phase? Here is 0, and here becomes pi, here becomes 2 pi, here becomes 3 pi, like this. So what should be the pi between this and this will be, if you take here pi by 2 and here 2 by pi by 2 plus pi by 2. So this becomes 2 pi. So the angle becomes 2 pi here. Fine. And that's what I'm going to call as a
Sir?
yes.
Sir, are we allowed to take the nodal points?
Anywhere you can take. You can take even this point and this point, where this point you can take easy. Yes, she has come to a very simple way. She wants to take from here to here. Fine, you take. Even here. Correct? 1 is equal to A sine of omega t 1 plus phi 1. At x2 is equal to A sine of omega t2 plus phi 2. It's clear? But both of them are the peak point you have taken here. So this equation must be equal to this equation. Therefore, A sine of omega 1 t plus phi 1 is equal to A sine of omega t2 plus phi 2. As simple as that. Now what I can cancel this into this. Sine also I can cancel. Therefore, I get omega t1 plus phi 1 is
Sir, one question.
omega t2. Ask me afterwards. Let me finish this. plus phi 2. Correct? Now, what I want to write here, omega, this T2 is equal to T1 plus T. This is what I told you. The time T2 is equal to T1 plus phi 2. Therefore, omega T1 is equal to omega T1 plus omega T. Therefore, I cancel this and this. So next step, you get phi 1 minus phi 2 is the phase difference now is becoming equal to T. But phase difference between this is 2 pi radians. 2 pi is equal to omega into T. So omega is equal to pi by T. This is the angular frequency. Arpan, you asked me now. You had some doubt.
Sir, oh, never mind, sir.
Okay. So this is angular frequency. So angular frequency is defined as the angular displacement per time. Rate of change of angular displacement is called angular velocity. It is the rate of change of angular displacement. Rate of change of angular displacement. That is omega is equal to d theta by dt is equal to 2 pi by t is equal to 2 pi f. That much radian per second. There is another quantity called angular wave number. Angular wave number. That is, this is K. Angular wave number. Angular wave number is given as 2 pi by lambda. Right? Whenever you have this 2 pi, you call it as angular. So angular frequency. Here angular wave number. You can write it as 2 pi into nu bar, where nu bar is equal to 1 by lambda. Called wave number. This is called wave number. So this is called angular wave number. Angular frequency, angular wave number. So this is called angular wave number. Is defined as angular wave number is defined as this 2 pi by lambda. It right away in this way. Angular wave number. Wave number is a reciprocal. Wave number is given as nu bar. Nu bar is a reciprocal of the wavelength. Therefore, one more term that I want to do here, I want to find out by k is equal to 2 pi f divided by 2 pi by lambda is equal to f lambda is equal to v. So another important equation I got you, v is equal to omega by k. Yes. So the velocity, right, can be given in terms of the angular frequency and the propagation constant. This is propagation constant, or I can call it as angular wave number. Anything I can use it. This way also I can write. K is the angular wave number. I can write the equation in terms of K also. Okay. Yeah. One more point to know, a few more points I want to add, and then I'll just come back to mock exam and other things. Okay. So this is something like examination oriented point I want to give you. Okay. So what and all we have got here, when a body is set into a sort of oscillation, oscillations, correct, like this is the mean position, this is the extreme position. At mean position, right, you have the formula V is equal to omega A square minus X square, correct? So at extreme position, velocity must be 0, correct? Because X become A, so it becomes 0. At which acceleration is, when this is minimum, acceleration will be maximum, minus omega square A. This is extreme position. So I write extreme position. At this position, the velocity becomes maximum and the velocity equal to, you see here, when this is 0, so you'll be getting omega A. So the maximum is omega A. And the acceleration, this is maximum, acceleration becomes minimum, that is equal to 0. So these points now you should remember very, very carefully. So I want to add some of the point here at this point. When the potential energy is equal to 0, potential energy is depending on the displacement. No displacement, potential energy is 0, but the potential energy is maximum here. Potential energy is maximum, right? Is this can be given as half k a square. K is equal to half, k is equal to omega square m. So m omega square a square is the maximum potential energy at which the kinetic energy is 0 here at this point, remember. And here the kinetic energy is maximum. Kinetic energy is maximum. Kinetic energy maximum means what? It should be half mv square, maximum velocity. You can substitute m v square, this is maximum, but maximum is omega a. So I can substitute here equal to half m omega square a square, kinetic energy. Whether you take mean position or any position, the total energy is constant. E is equal to half m omega square a square. Even here also, E is equal to half m omega square a square. Anywhere in between also, if you take, let us say, you are taking at some point somewhere here, right? The total energy is the potential energy plus kinetic energy. This potential energy can be given as half k x square, and here you can write half m v square is equal to E. So this value can be written as half m, m omega square into x square, omega square into x square. And here I can write here half m. V square is nothing but a square into omega square minus x square. Even if you write here, this total energy will be equal to this energy. This is equal to this energy, equal to this energy. This is what I just want to give you for the examination point of view. Right, hope you understood this one. So a little bit now I can add some more points with some simple pendulum, and all these things are there as a general question. Some simple pendulum I want to give some idea. So I take here simple pendulum. In the case of simple pendulum, here we have, look at this one, this is a simple pendulum. It is swinging here. This is the extreme position. This is the main position. Correct? So the two positions are there. One is extreme position, other one is the main position. So both the positions I have taken here. Now, we want to, we have, this is the L and the time period is T. And T is the time period. We know all of you know the formula that T is equal to, or G is equal to, you can write here, or we can write 4 pi square L by T square is equal to G, the acceleration due to gravity. You know this formula. All of you know this equation. G is constant on the surface of the Earth. G is constant on the surface of the Earth. Therefore, you know that L is proportional to T square. So, if there are two lengths, L1 by L2 is equal to T1 by T2 the whole square. All these things you must have right for these exams. You should remember some extra points also given on the oscillations. Remember all those. Correct? If you have any doubt, you can just ask me. Now I can go to the other part, which one I can teach you the mock exam and other semester examination portions. Any doubt? Any doubt? So the extra part what you have seen here is this. What is that?
Sir, excuse
We have connected
me, sir.
omega and k, and some energy terms are
Sir,
given for the
excuse me, sir.
yes. Yes, tell me. Niket. Fine. So this is what we are seeing. I'm not able to hear you. Syed.
Sir, can you hear me?
Yes, tell me.
Sir, if V square max
Yes.
in the mean function, then it will be omega square into n, sir.
Your voice is not clear.
Sir, if V square max velocity is maximum in mean position, then it would be omega square into n, sir.
Where V is equal to omega into a square minus x square, how we get omega square? V is equal to omega into a square minus x square. This is a formula. Correct?
Sir, if it is in the mean position, then
this
the
is
x will be 0, sir.
In the mean position, x becomes 0. The square root of a square is a. So omega a. Omega.
Okay, sir. Okay.
Okay. Fine. This is what now we have seen. So up to this has been included for the midterm examination. Now I go to the next part where I'll describe about the mock exam and the midterm examination and everything. Okay. This is about the test. I'll first show you the instruction. After that, we'll see all the other things. Okay, now this. Okay. Okay, all of you able to see this? Say yes. Somebody can say no. Fine. So look at this one. So this is what I already posted to you in a Google Classroom. You will have, we are conducting a test this way. All of you listen to me very carefully. For another some 20 minutes, you should be, very right careful in listening to all these things. And you have, there are section A and B, section B. Section A will be of multiple choice and section B will be concept questions. And, correct? And you have one more part that will be okay. So you have section A and section B. That's the first one. Okay. So in section A, this will be conducted at 9:30, and you'll be given 70 minutes for this one. Remember, 1 hour question only, 10 minutes for uploading and submitting all those things. So 10 minutes extra is given to you. In this section, 30 questions will be of 1 mark question, and 15 questions will be of 2 marks. In the question itself, it will show that 2 points and 1 points. Whenever you find 2 points, it will be like 2 mark question. Whenever you find that as a 1 point, it is a 1 mark question. So both the questions will be combined together. Correct? Both the questions will be combined together. Correct? So it will be conducted for between 9:30 and 10:40 on 19th. Okay. After that, we'll do this normalization reduced by 2 and all, so that we'll be calculating that for 30 marks. That is up to us to do this. Okay, the second concept question, we will start at 11 o'clock and it will go up to 11:40, where these questions, you will get the question paper in the Google Classroom, where you have to write. You will not be monitored at all, but you must be genuine. correct? All these questions are 2 more questions, the concept type questions only. You can use a half page for writing the answer. Write neatly on A4 sheet, and then you can take a photocopy of it, camcorder or anything you can use, so that that can be copied, and that should be properly uploaded. For that purpose only, we are giving 10 minutes extra. Uploaded into Google Classroom. That is similar to whichever way you write the assignment. So you don't have to much worry about the second part. It is something like a submission of an assignment. But in the first part, section A, what you have to do, you have to choose the right answer there, and you have to click there only. Is a multiple choice question. So in the circle, you have to click whichever question you find that is suitable or correct. And there you can just put, you can click. If you click it, it will mark as a dot will be, a black dot will come there in the circle. That means you have chosen that right question.
Sir, in
Then,
which platform we will be doing section A?
Section A and section B, both of them you will be doing in Google Classroom only. One is a quiz assignment, another one is a concept question. It is an honorary assignment. Quiz assignment, you have to give the answer immediately. That computer itself will value and will give us the grade. Both of them are performed.
Navigation will be allowed, right?
Yeah, Avani, repeat.
So navigating back and forth in the questions, like for example, if we don't know how to do question number 1, and
yes,
we can just
you will be very good. You want to just see the question that you already attended. You want to just redo that one that is available, because all questions will be available in the page where you can scroll down or up. You are allowed to change also. Okay, so what I'm going to do here, I'm going to give you a mock test today itself. So you tell me what time you can take a mock test. Maybe at 5 o'clock you can take, so that I can open the mock test link to you at exactly 5 o'clock today, so that you can finish. I put only some 8 questions over there as a mock test, right? You can just do.
Today actually both PCM and PME have. Oh yeah.
One of you speak, I'm not able to. Yes.
So we have an extra English class today from 4 itself. So it would be tough to have an exam today.
Yeah, and we have an exam from tomorrow. We have the midterms from.
Right. This is a mock test. You'll be spending only some 10 minutes. That's all. I just want to give you a practice. That's all. You don't have to spend much time. You're going to spend after all 12 minutes, and you're going to learn this one, how you are going to operate, how you are going to answer your questions.
So actually, we have a maths asynchronous assignment also after that. So it will be very stressful. Can we do it tomorrow in the morning or something?
Yeah, anytime, no problem. It's a mock test only. Whichever time that you say that you can do it, or I can put in the night at 10 o'clock, 8 o'clock. Okay.
Sir, or else you can do it after the Friday's class.
No. I want to give it before. It's just a mock test only. Be comfortable, because it will be useful for you for electronics or chemistry paper also, or mathematics paper. Yeah, it is. Anyway, that one we'll decide later. I'll just let you know. Otherwise, shall I do it this way? I'm giving mock test. Anytime, whenever you are free, you can take it. Is that okay? That way I can put it? I can
yes, sir. So that would be
yes, sir. That's a good.
Yeah, I can put the due date as next Saturday, Sunday, the coming Sunday, so that anytime you are free, you can take it. That mock test. Will that be okay?
Yes.
Yes, that will be better. Oh, yes. Okay, let's come to the actual part, how it is coming here. This is how it is coming. So the test line, the timeline will appear this way. MSc mid-semester exam, October 2020, PHY 131, mechanics, quiz, PCM PME. And the time is, this is due date, 10:40, automatically it stops. You will not be able to upload. Keep that in mind. You are expected to upload it before time. Even if it is 41, you will not be able to upload this, because the due time, the time is given like this, 10:40. So attempt all questions. 1 to 30 will carry 1 mark, and 31 to 45 will carry 2 marks. But you remember, in the question paper, all 1 mark and 2 mark questions will be mixed. And on the top right corner, it will be written like 1 point, 2 point. That means 1 point means 1 mark, 2 point is 2 mark question. That you'll get to know. The total duration of the test is 70 minutes. No negative mark will be given for the wrong answers. You are expected to answer all the questions, attempt all the questions. Submit the form well before the due time. So if it is 10:40, I expect you to submit. Right at the end, you have to click submit. That's all. That may not take much time. Correct? At the end, you have to you have the submit button. There you have to press it. That you do it before 10:40. And the second part, the concept question, that will be conducted on the same day. At 11 o'clock, I am starting. It will get over at 11:40. So due is 11:40. Correct? Due is 11:40. This will take even after 11:40 also, but it will come late. So you'll be losing your mark. See that you are doing it 11:40 itself before that. Whereas here you will not be able to submit after 10:40. So I expect all the students to submit, look at the due time, and accordingly you submit it. Before 10:30 you have to submit it, and here before 11:40 you have to upload it, like an assignment. In this, you are going to use A4 sheet, white sheet, all of you keep it ready. Answer all 10 questions. If you don't have any choice over there, and each question carries 2 marks. This is a concept question. And do not ask for any concession bandwidth or anything. Keep everything ready. Data and all, keep ready. And it will be conducted only that particular time. Keep everything ready. So I will not be able to, because I do not have any control. I have to just initiate it. I will start it. I will assign all of you at that particular time. After that, I do not have any control. Remember, only computer does it. Only that Google platform is conducting all those things. And duration of this test is 40 minutes. Do not exceed a half page for each question. All questions must be uploaded neatly as a single file. No negative mark for wrong answers. Submit file well before the due time.
Sir, will there be any choice between questions?
The questions I'll show you, right? 1 more, 2 more questions. The quiz part, right? That is, you are writing in 9:30 to 10:30. This part, the first part, that is section 1, will be like this. This is the type. This is similar to your CET or your which exam, NEET exam, right? It will come like this. So you have to put a tick mark there. Now one circle will come. There you have to press it. That's all. This is some sample questions, and I have put here like this. So I'm talking to you about again the model mock exam. Mock exam. I'm just
those questions were 2 marks or 1 mark?
There are 1 mark questions. 30 questions will be of 1 mark question, and 15 questions will be of 2 mark questions. So totally 43 questions. Okay, fine. So the mark for mock exam, I'm just the due date I'm putting only on Sunday. So anytime you are free, you can just open it, and then you can take the mock exam. Right? Only once you can take it here, immediately the mark will come to me. So only some 8 questions I put as a sample question, and you can take test for that. Okay, probably some 10 minutes, 8 minutes you set, and then you can put a tick mark, and you'll be able to get this.
Sir?
Yes.
So will there be derivations in the concept questions?
Look at this one. There can be a small derivation which can be derived in 3 lines or 4 lines. Such parts, some derivations may be there. So you don't call it as a big derivation as such. Maybe a small part, right? Within 3 steps, you'll be getting it. Yes. Anything else?
Sir, will the questions be in the same way that the question papers from the previous years are?
Question papers are previous years. This is a 2 mark question, totally new type of question. So you do not have any previous year's questions here. All new type of questions.
Okay, sir.
Okay. Any other doubt you can ask?
me, sir.
Yes.
Sir, the matter for the examination is until what we did today, right?
Yes. Whatever I completed right till now is there for the midterm exam.
All right.
And George Thomas sir also has put his syllabus in the Google Classroom. I saw is there. So you know the syllabus.
Sir, could you post some questions from oscillation so that we can get an idea what type of questions will come from that?
Look at this one. Oscillations I've just taught only for some 3 or 4 class, 3 class only, or 4 class only. You have all the recording over there and you have all the slides. You just go through this. The questions will be coming from there. That's all.
So previous class recording is not available on Google Classroom.
I just went through. There was some. I put it and later it was not playing all right. Anyway, I'll check it out. I'm not able, but you have the slides neatly. No, that is enough.
Okay, sir. Thank you.
Your preparation should be something like, it should be a concept-oriented preparation. You don't have to derive any bigger equations here, but it should be something like key points, you should remember. Something like, excuse me, what is the potential energy at the mean position? What is the kinetic energy at the extreme position? Something like that, they may ask questions. Yes, anything else?
Sir, we haven't taken attendance.
Yes. Please type your attendance